Okay, so we're talking about two extremes here. On one hand, you've got these massive new factories, and on the other, AI is so small it could literally fit on the head of a pin. We're going to dive into how India is making this huge, high-stakes gamble to reshape the entire world of tech. And there's one year you really need to keep in mind, 2026. This is the big one. It's a critical milestone, a date that's been circled on the calendar for a massive global ambition.
Why? Because 2026 is the year India's semiconductor dream is supposed to get real. We're talking brand new chip manufacturing plants, firing up their machines, and starting commercial production. This is where all the planning turns into actual physical stuff.
All right, first things first. Let's start with the big picture, and I mean big. We need to talk about the sheer scale of India's national strategy to build a domestic chip industry, basically from the ground up.
So by 2026, the plan is for 4 major plants to get up and running. We're talking big names here, like Micron and Tata Electronics. They're supposed to go from just testing things out to full-scale production. And look, this isn't just some symbolic thing. It's an absolutely crucial step to make the country's supply chains more secure. It really marks the moment India's whole semiconductor journey goes from plans on paper to actual production lines.
And if you want to know just how serious this is, look at this number. We're talking about a cumulative investment of over 1.6 lakh crore rupees. To put that in perspective for you, that's more than 20 billion US dollars. That's from both the government and private companies. This is a serious bet.
You know, what's really driving this is the realization that this isn't just about business anymore. The last few years, with all the global supply chain chaos, have taught every country a really hard lesson. If you can't make your own chips, you're incredibly vulnerable. So for India, and honestly for a lot of other places, making chips at home has become a top national priority. Okay, so we've talked about these giant factories. Now I want you to completely shift your perspective. We're going to pivot to the total opposite end of the scale, into the microscopic world of cutting-edge AI research. Because this is the question that could change everything. We've been talking about this huge macro-level plan, but what if the real revolution, the truly disruptive stuff, is happening on devices so small you could balance them on your fingertip? And this chart, wow, this really shows you just how massive that challenge is. Just look at the numbers. A microcontroller, that's the tiny little brain inside billions of smart devices, it has a memory that's literally thousands of times smaller than your phone. We're not talking gigabytes here, we're talking kilobytes. It's a crazy gap to bridge.
And that's where this thing called TinyML comes in. TinyML stands for Tiny Machine Learning, and it's basically the science of getting powerful AI to run on these incredibly constrained, low-power, super cheap devices. You know, the ones that are in everything from your coffee maker to industrial sensors.
I mean, it sounds almost impossible, doesn't it? How in the world do you run a supercomputer's brain on a chip that has the memory of a housefly? That's not an exaggeration, that's the scale we're talking about. And this is the exact problem that researchers at places like MIT have been trying to crack.
Well, the answer, it turns out, is a breakthrough called MCUNet. And the genius of it is this. Instead of just taking a big AI model and trying to shrink it down, MCUNet designs the AI brain, the model, and the engine that runs it at the same time. They're co-designed, optimized for each other, right from the get-go to be unbelievably efficient.
And get this, the results are absolutely stunning. This chart here shows that for a really complex task like recognizing images, MCUNet uses 3.5 times less memory than a top-of-the-line mobile AI model. And it's actually more accurate. It just completely shatters that memory barrier.
So how does it pull this off? Well, the old way was kind of like having a slow, clunky interpreter that wasted a ton of memory just trying to figure out what to do in real time. Tiny Engine is totally different. It generates specialized, custom-fit code for the AI model before it's even put on the chip. All that wasteful runtime stuff, gone. And that makes it dramatically faster and way smaller.
And this number right here, this is the payoff, 70.7%. For the very first time, researchers got over 70% accuracy on the gold standard ImageNet test using a regular off-the-shelf microcontroller. This was something people thought was pretty much impossible. The era of tiny machine learning is officially here. And for a country like India, you can imagine what this means. Smarter, more efficient devices in everything from farming to healthcare, all powered by homegrown technology.
Okay, so we've got the giant factories, we've got the mind-blowing tiny tech, but let's talk about the third and maybe most important piece of this puzzle, the people.
I mean, think about it. We have these giant factories and brilliant AI for tiny chips,
But who's actually going to build all of this? It's a fundamental question, right? All this incredible technology and grand strategy, it all comes down to having a pipeline of highly skilled engineers who can design, build, and run the whole show.
And you know what? It all starts right here, with the absolute basics. This slide is from a handbook for what's called VLSI design. That's just the fancy term for creating these complex microchips. It's a reminder that every fantastically complicated chip in the world is built on a foundation of pure logic. You have to understand something as simple as the binary system. That's the first step on the ladder to building the future.
And this quote from Prime Minister Narendra Modi really connects the dots perfectly. He says, "Skilling is building a better India." The national vision isn't just about pouring concrete and building infrastructure. It's explicitly tied to a mission of developing skills, of creating the human talent that's needed for a high-tech future.
So how does that actually happen? Well, this is how. You have organizations like the Electronics Sector Skills Council of India, and their entire job is to create the specific curriculum and the training programs needed to produce a workforce that's ready for these super specialized jobs, like VLSI design engineer.
All right, so we've looked at three pretty different things: the massive factories, the tiny AI, and the people. So now let's put all three of these threads together and see how they form one single cohesive strategy.
So when you boil it all down, it's really a three-pillar approach. Step 1, you have the strategic policy, the government coming in with massive funding and approval for manufacturing. Step 2, you have advanced innovation, with researchers developing groundbreaking tech like MCU, so India can lead, not just follow. And step 3, you've got this national mission for talent development, to skill up the engineers who are needed to power the first two. These aren't just separate ideas. They are all designed to work together, to feed into each other.
So if there's one big thing to take away from all this, it's this. India's strategy isn't just about building factories. That's only part of it. It's about creating the full stack, the policy, the cutting-edge research, and the people. The ultimate goal here is to build a semiconductor industry that's resilient, complete, and can compete on the global stage. So India is building the factories, it's developing the AI, and it's training the talent. All the pieces are being put on the board. The big question that's left is, will this be enough? Will this massive three-pronged bet be enough to create the world's next global tech powerhouse? I guess we'll all be watching to see what happens.